Okay, this tutorial is about elements and atoms. You may have discovered that elements are substances that you cannot break down by chemical reaction. That's unlike molecules that you can break down. So water would be an example of a molecule because it's made of hydrogen and oxygen. But hydrogen and oxygen you can't break down into smaller parts by chemical reactions. Those are what elements are. Elements, the smallest part of an element is called an atom. And you can break our atoms down into parts, and we're going to learn about those parts during the course of this video. But the parts are not unique to the element. So an atom is made of protons and neutrons and electrons, but all atoms, doesn't matter if it's an atom of oxygen or hydrogen, are made of those things. Whereas something like water is composed of the elements, hydrogen and oxygen. So you can break water down into those elements, but you cannot break the elements down. You can't break hydrogen down or oxygen. So that's what makes it, that's the difference between them. So today we're going to concentrate on the elements and atoms, that element's the smallest part of an element, which is an atom, and we'll get to molecules later on. All right, we're going to talk about atoms. We're going to go through a PowerPoint presentation about atoms. And you could here see a generalized picture of an atom. And it has three parts. Every atom has three parts. They have protons, neutrons. There's actually one kind of atom that doesn't have neutrons, but in general atoms have neutrons and electrons. So the three parts of an atom: proton, neutron, electron. Protons and neutrons both exist in the nucleus. That's the center of the atom right here. Protons have a mass of one atomic mass unit. That's equivalent to how big they are, how much they weigh. We're not going to really spend a lot of time on the size of a proton or the size of a neutron, but we do need to know what their mass is. So a proton and a neutron actually both have the same mass. They have a mass of 1. So they're relatively heavy compared to an electron. Electrons, as you can see, are out here, and they actually move around in what we call orbitals. And you can see there's an orbital here, an inside orbital, and then there's another outside orbital. You might have learned of these as electron shells. They don't really look like this. This is just a way for us to talk about them. And you can see that some electrons are in this inner shell and some are in this shell, and there are actually more shells. So there'll be another shell out here and another out there. We'll get to that in a moment. Electrons are very small. They have a zero, they aren't really zero, but we would call it no mass. Some other differences between protons, neutrons, and electrons: protons have a positive charge and electrons have a negative charge. Neutrons have no charge, which is why they're called neutrons. They're neutral. So that's our generalized atom. We'll go to our next slide. Oh, I go too far. That's what happens. So if we have our protons and neutrons in the nucleus, you can see that these are electron shells. We can think of these shells as having different energy states, where the inside shell is the lowest energy state and the outside shell is the highest energy state. So an electron in this shell has a lot more energy than the electron in the inside shell. And I made this little picture to show you that, it's sort of like if this guy, threw this rock off of this cliff, it would have actually less energy than if this guy threw his rock off. So, Wile E. Coyote, when he's after the Roadrunner, was always trying to push a rock off onto that Roadrunner. He'd be pushing it from way up here to get as much bang for his buck as he could. But of course, Roadrunner would have outsmarted him or something. Or maybe this is Wile E. Coyote and Roadrunner would have outsmarted him and had a rock above him. But anyways, here's our levels. Electrons prefer or are most stable at the lowest energy level. So they don't really have preferences, but you can think of an electron as wanting to be at the lowest energy level that it can. The problem is not every single shell can hold unlimited numbers of electrons. So the inside shell, or the lowest energy shell, can only hold 2. Every other shell holds 8. So this one would hold 8, this one 8. That's a bit of a simplification. That isn't really true, but for our purposes, we're going to say that the inside shell can hold 2 electrons and every other one can hold. Okay, so now we want to talk a little bit about the different kinds of elements. So if we look at a periodic table of the elements, which I just pulled up on a website, and you have a handout that I gave you in class that has basically the same information on it. This shows us all the different kinds of elements there are. So as we talked about before, an atom is just the smallest amount of one of these elements. So one atom of carbon would be just one atom of this element carbon. You notice each of the elements has a symbol. H is for hydrogen, Li is for lithium, Na is for sodium. That's a little interesting one. If we go over here, carbon is C, nitrogen is N, oxygen is O. So most of them are pretty straightforward. Each of these elements, when we look at an atom of oxygen, it's always going to have one thing that's the same. No matter what, it's going to have the same number of protons. All atoms have the same, of one element, have the same number of protons. So if I blow this up a little bit and we look, we see that each of these elements has a number. So hydrogen is 1. And we go all the way over here, helium is 2. Go back over here, lithium is 3, and beryllium is 4. Carbon is 6. That's called the atomic number. So this number here is the atomic number, and that actually tells us the number of protons in an element, or in an atom of that element. So it's the number of protons that dictates which element we're looking at. So if I said, which element has 16 protons in an atom, you would go over here and you'd say, sulfur. If I said, which one has 2 protons? Helium. Because no matter what, an atom that has 2 protons is always helium. An atom that has 8 protons is always oxygen. Don't worry, you won't have to memorize this. So that tells us the number of protons. Now, we always assume when we start that every atom is neutral. That isn't always going to be the case, but for now, we're going to assume that an atom is neutral electrically. That means that there's going to be a balanced number of protons and electrons. So if we have 6 protons, instead of 6 protons, we're going to have 6 electrons. So that's pretty straightforward. We look at carbon, we say, 6 protons, it's also going to have 6 electrons. Nitrogen, 7 protons, it'll also have 7 electrons. Finally, we want to know how many neutrons there are. Well, remember I told you that protons and neutrons are both have the same mass, so they both have a mass of 1, whereas electrons have no mass. They're so small. They actually have a little teeny weeny mass, but it's like 1/2000th of a proton or a neutron. So because they have such a small one, we're going to say it's 0. So when we look at the total mass, which is down here, this is called the atomic mass of each element. You can see there's this number, it's 12.0107 or 14.0067. For our purposes, we're going to round that off to the nearest whole number, because this is really an average. Right? So this is an average over all carbon. We can talk about what that average might mean. It also takes into account the mass of the electrons, which we're not going to. So for our purposes, if we look at carbon, we're going to say, look, the mass is 12, but there's only 6 protons. Well, we know there's 6 electrons, but they don't contribute to the mass, so where do the other 6 atomic mass units come from? They come from the neutrons. So we know that there are 6 protons and 6 neutrons in carbon, and we know 6 protons from here. We know 6 neutrons because 6 and 6 is 12, and we know there are 6 electrons. This isn't always the case that there's an equal number. You're going to see that often there is 7 protons in nitrogen. The atomic mass is 14, so there must be 7 neutrons. Same thing here, 8 protons in oxygen. There must be 8 neutrons because this is 16, right? 15.9994 is really 16. But there are some that's not the case. A good example is sodium. Sodium has 11 protons, but it has an atomic mass of 23. So that means there must be 12 neutrons to match that 11, to add to the 11 protons to get to the 23 atomic mass. So I want you to look at this, and remember we talked about that hydrogen has a atomic number of 1, which means it has 1 proton. and it has a mass of 1. So, does it have any neutrons? This 1 atomic mass unit comes from the proton. So, there are no neutrons. So, we know it has no neutrons. Do you remember how we determined how many electrons there were? Remember that in a neutral atom, there are going to be equal numbers of protons and electrons. So if there's 1 proton, there'll be how many electrons? 1. So now we're going to create an actual model. So I'm going to go over here, and we're going to say hydrogen has 1 proton. So there's the proton, and it has 1 electron. And electrons are in orbitals, remember, around the nucleus. So there's our 1 electron. Very simple. And this model, by the way, is called a Bohr model. So it's a Bohr model of hydrogen. It's named after Niels Bohr. Next one we're going to look at is helium. So let's go back to our periodic chart, and we're going to scoot over here to helium, and we're going to see helium has 2 protons, so it must have 2 electrons. It has an atomic mass of 4. So 2 protons and 2 neutrons would make an atomic mass of 4. So let's make a picture of helium. We'll have 2 protons in the nucleus. We'll also have 2 neutrons in the nucleus. And then we have an orbital with 2 electrons. Now remember I told you that these orbitals can only hold a certain number of electrons. In this case, in every case, the inside orbital can hold 2 electrons only. So this orbital is full. We say that that orbital is full. Whoops. So next one I want to do is carbon. So if we go over to carbon, here we are at carbon. We talked about carbon before. Carbon, there are 6 protons. There's an atomic mass of 12. So how many neutrons are there? And think about how many electrons there are. Let's build our model. Here's carbon. There's our 6 protons. And because the atomic mass is 12, there must be 6 neutrons. There also are 6 electrons. Now, in this case, we're going to need more than 1 shell. We know that you can put 2 electrons in the first shell. The next shell is going to hold the remainder of those electrons. That's 4. So we have 2 orbitals here. First, we always fill the inner one because that's the one at the lowest energy level. And then we add the electrons to the next level out. This level is going to be very important to us because the outside shell, no matter what it is, for hydrogen, the outside shell was the inside, was this inner shell. There was no other shell. For helium, it was this shell. But for carbon, it's this shell. This outside shell is going to tell us how that atom behaves with other atoms. So how does it form bonds with other atoms? How do we make molecules out of this? That shell is called the valence shell. So the valence shell, these are valence electrons. Those are very important to us. So if I asked you how many valence electrons are in carbon, you would just count up how many are in this shell. 1, 2, 3, 4. 4 valence electrons in this shell. Valence electrons. 6 electrons altogether, 4 valence electrons. We got another one here, neon. All right, so let's look for neon. I'll go over here to neon, and here's neon. And you can see neon has 10 protons, atomic mass of 20. So now we know we can all the stuff we need to build that particular model. So neon, we're going to have a bunch. Now I didn't draw all of them, but there are 10 protons and 10 electrons. So there they are. Just imagine this 10 and 10, but you start running into trouble trying to draw them all in there. And there must be 10 electrons. So again, 2 in the inner shell. And then in the next shell, we would put the remaining 8. Remember that this shell can only hold 8, right? That's the maximum number, but they're all there. Notice now I'm showing electrons paired. In reality, electrons do tend to occur in pairs. So we're going to show them paired, and that's going to be important also for bonding. How many electrons are in the valence shell here? 8. And because no other electrons can fit in this shell, we say the valence shell is complete. In general, atoms are most stable when their valence shell is complete. So they're trying, if you could imagine an atom trying to be stable, it wants a complete outer shell, a complete valence shell. If there are electrons in this shell, complete means 8. For hydrogen and helium, complete would mean 2 because they only have one shell. So you always look at this outside shell to determine what the valence electrons are and whether the atom is stable or not. If it's not stable, it's likely to form a bond with something else. This is a shorthand notation to show us how many electrons are in the valence shell. So for hydrogen, there was only one electron, and so that one electron was in its outer shell. So there we have it. One electron is shown next to the symbol for a hydrogen. So this is a shorthand to show us the number of valence electrons. Carbon had 4 electrons in its valence shell. Neon had 8. And so this is just a shorthand notation which we will use again in the future. All right, finally, here are some things you need to know for the quiz. You need to know that atoms are composed of 3 parts: protons, neutrons, and electrons. You need to know that protons and neutrons have a mass of 1 atomic mass unit. You need to know that electrons don't have a mass, so 0, even though that's not really quite true, but know that. Know that protons have a positive charge, electrons have a negative charge, and neutrons have a neutral charge. That means no charge. You should know how many electrons each orbital can hold. The inside orbital, or shell, can hold 2. All other orbitals can hold 8. You should know what the atomic number tells you. The atomic number is the number of protons in an atom of that element. You should know what the atomic mass is. The atomic mass is the number of protons plus the number of neutrons. And you should know what a valence shell is. That's the outside shell of an atom. And that tells you how the atom will behave. Good luck on the quiz.